Elastic collision: when two bodies collide in such a way that the total kinetic energy and the total linear momentum of the system remain conserved. That is, before collision, the total kinetic energy of the system of particles plus total kinetic energy, total linear momentum of system of particles equal to, after collision, total kinetic energy plus total linear momentum of system of particles. Then the collision is said to be elastic collision. We now find out the velocities of two bodies after elastic collision. Let us find out the velocities of two bodies which suffer elastic collision after the collision. Say we are having two bodies. Say this is body A. This body A is having mass m1 and initial velocity of this body is u1. Similarly, this is body B. It has a mass m2 and it is moving with a velocity, say u2. So before collision, u1 is greater than u2. They are moving in the same straight line. Now after collision, suppose the velocity of A, this is A, suppose the velocity of this body A becomes v1 and velocity of body B, it becomes v2. Now we have to find out, this is after collision, so we have to find out the velocity of A and B after collision. Now we will use the principle of conservation of linear momentum as well as conservation of kinetic energy, which remains same in elastic collision. Now here the linear momentum of A is m1 plus u1, m1 u1. Linear momentum of B is m2 u2. So total linear momentum of the system before collision is m1 u1 plus m2 u2. Similarly, linear momentum of A is m1 v1 and linear momentum of B is m2 v2. So therefore total linear momentum of the system after collision is m1 v1 plus m2 v2. So we can formulate equation 1. We are taking m1 in one side and m2 in other side. Now as we know that in elastic collision the kinetic energy is also conserved. So kinetic energy of A is half a1 u1 square plus kinetic energy of B is half m2 u2 square. This is before collision the kinetic energy of the system. Kinetic energy of A after collision is half m1 v1 square. Kinetic energy of B is half m2 v2 square. So we are again separating m1 and m2. M1 taken on the left hand side. So we get equation like this, that m1 u1 square minus v1 square equal to m2 v2 square minus u2 square. Now let us split it, a square minus b square. So a minus b, a plus b. Now from this equation, m1 u1 minus v1 means this part. m1 u1 minus v1 is nothing but m2 v2 minus u2. So we can directly put this value of here. So it becomes m2 u2 v2 minus u2, this plus u1 plus v1 equal to the right hand side. Now m2 cancel out. Okay, so v2 minus u2 is in both the sides. So therefore we conclude that v2 equal to u1 minus u2 plus v1. So we are having now two equations. One is m1 E1 minus V1 equal to M2, V2 minus U2, and second is equation is V2 equal to U1 minus U2 plus V1. Now with the help of these two equations, there are two variables, that is V1 and V2, and two equations. So we can solve these equations to find out the value of V1 and V2. So by putting the values of V2 from equation 2 in equation 1, we can find out the value of V1 here. So V1, this gives the velocity of the body A after collision in terms of initial velocity of A and B and their masses. Similarly, this equation, suppose we know the value of V1, if we put the value of V1 here in equation 2, that is, if we put equation 3 in equation 2, so we can find out the value of V2. So again, V2 is the final velocity of body B after collision. So this gives the velocity. Now, so using equation 3 and 4, we can find out the velocities of bodies after elastic collision. We now analyze some special cases. Say a ball suffer elastic collision with the wall. So we have to find out the velocity of the ball after collision. So here, suppose A is the body, that is the ball. So the mass of the ball is much less than the mass of the wall. Now here the velocity of the initial velocity of the wall, that is U2, this is 0. So from equation 3 we find that V1 equal to this is M1 is mass of the ball, this is negligible, so we can neglect M1 in comparison to M2. So therefore we can write this is minus M2 is mass of the wall. Again M1 can be neglected from the denominator, this is again in the denominator also, this is M2. E1 is the velocity of the ball plus U2 is initial velocity of the wall, so this is 0. So we find that this is nothing but minus U1. That is, when the ball collides with the wall with a velocity E1, it rebounds with opposite velocity minus U1 after elastic collision. So V1 equal to minus U1. Okay, V2 is velocity of the wall after collision. We can see that M2 is much higher than M1 and U2 is 0, so V2 equal to 0. Say V2 equal to, this is U2 is 0, initial velocity of the wall, that is why the first term is 0. The second term M1 is divided by huge mass M2, so this is 0, that is velocity of the wall is 0. Now case 2, suppose there are two identical balls and they are moving in opposite direction but with the same speed. Velocities directions are just different. It means that E1 equal to, E1 is the velocity of the first ball, then U2 will be equal to minus E1. The directions are different. So from this equation V1, this we can find out V1 equal to, this is two balls are identical, their masses are same, so M1 minus M2 is nothing but 0 because they are identical. So the first term is 0, second is 2M2 by M1 plus M2 means both are having same mass. So if that is 2M2 again here, so 2M2 by 2M2 0, this is U2. So V1 equal to U2. It means that the first ball after collision will attain the velocity of the second ball before collision, that is V1 is U2. Similarly V2 is velocity of the second ball after collision. So the first term again here from equation number 4, M2 minus M1 means both the balls are identical, their masses are same, so first term is 0. This is 2M1 by 2M1 because masses are same, so this 2 cancel out, this is E1. So V2 equal to E1, that is velocity of the second ball after collision is equal to the initial velocity of the first ball before collision. So they collide elastically and then after collision they get separated with the same just the velocities are interchanged. Okay, now a moving ball collides with a stationary ball. Suppose this is a ball, it collides with a stationary ball. So u2 is 0 here. So the velocity of the first ball v1, and both the balls are identical, so first term is 0, m1 minus m2, both the balls are having same mass, so this is v1 is 0. The first ball after collision will come to rest. These balls are identical, so their size, shape, masses are same. Now velocity of the second ball v2 is m2 minus m1, both the balls are identical, their masses are same. The first term is 0. This is 2m1 by m1 plus f2 u1, that is 2m2 by 2m1 by 2m1, because masses are same, so these two cancel out, so v2 equal to u1. That is, the second ball moves with the velocity equal to the initial velocity of the first ball. That is, this ball will hit it, and this ball, the first ball, will come to rest, and second ball will move with the velocity of the first ball. So similarly, different cases can be analyzed to find out the velocities of two bodies after elastic collision by with the help of equation 3 and 4.